Hello dear student, how is it everyone? So this is lecture number 4 of this chapter metal and non-metal. So yet we have seen lots of concepts. Now let's move on to the next slide. Okay students, so here we will talk about the reaction of metals with metal salt solution. So basically we already seen this reaction in the first chapter. This is basically the displacement reaction. So you can see that this is copper sulfate, and when this copper sulfate reacts with magnesium, then this magnesium will displace this copper and it will take its place, and another substance, magnesium sulfate, will be formed. Okay, so because you can see that one element is displacing the other element, that is why this reaction is known as displacement reaction. Now guys, you might be wondering that why this is happening. So basically guys, as we all can see, and we also saw this in the previous lecture, that there is a reactivity series of the metals. So some metals are highly reactive, some metals are, let me write it here, highly reactive. On the other hand, there are such metals as well which you can say in reactivity series they are moderate reactive, and there are some metals as well they are less reactive. So guys, what happened, this highly reactive metal, because it has high reactiveness, so that's why it will displace the metal which is less reactive. So that's why this reaction, you can see magnesium is replacing copper. So we can also write another example. Let's suppose we have this iron. So when this iron reacts with copper sulfate, then because iron is more reactive than copper, so it will displace copper and it will take its place, and ferrous sulfate will be formed, and this is copper. So guys, this is another example of the displacement reaction. So I'm again writing the reactivity series here: potassium, sodium, calcium. These three metals are highly reactive, then magnesium, then aluminium, then zinc, ferrous. Okay, these are, you can say magnesium is moderately reactive, aluminium, zinc and ferrous, these are less reactive as compared to the metals which are above aluminium, zinc and ferrous, and copper, silver and gold. These are least reactive. So highly reactive metal will displace the less reactive metal from its compound. I hope guys this point is clear to you. Now after understanding this point, let's talk about what is on the next slide. Okay students, so here we are. Now this is basically an experiment. So in this experiment, what we are doing, we are actually have taken two test tube. This is test tube number first. Okay. Now what will happen, guys? This test tube first basically have the blue copper sulfate solution. It has, let me write it here, copper sulfate solution, and this is blue in color. Now what we are doing, we are adding magnesium powder in this. So we all know that magnesium is highly reactive than copper. You can see this here, that magnesium is coming above than copper, so that's why it is more reactive than copper. So guys, this will displace the copper from its compound and it will form magnesium sulfate plus copper will be separated. So you can see in this test tube that after adding the magnesium powder, magnesium sulfate is formed, and these are the pieces of copper. So I hope, guys, this example is clear to you. Now we will talk about this second example. This is also very famous example. So guys, you can see that we have again take a test tube. So in this test tube we have the solution of copper sulfate again. Okay, now in this experiment we are doing something different. Here we have added the magnesium powder, but here we are actually adding the nail of iron. This is iron nail. So we are dipping this iron nail into this solution. Now guys, after 15 to 20 minutes, what we will see or we will observe that this blue copper sulfate solution will turn into green iron sulfate solution, because this iron which was present in this iron nail will displace the copper from its solution and it will form green iron sulfate solution. And this metal, this copper metal will be seen, or it can be seen here on this nail. So I hope, guys, this point is clear to you. You can see that the color of this nail become brownish, okay, and the color of the solution becomes green. So we can also write this equation for better understanding. So this ferrous, let me change the pen, this ferrous will react copper sulfate, and because it is coming above on the reactivity series, so it will displace copper from its compound, and ferrous sulfate and copper will be the product. And because this ferrous sulfate is green, that's why this test tube will also become green, or you can say the solution, the color of the solution will become green. So I hope, guys, this reaction which we have seen here is clear to you. Now you can also see that even when zinc react with copper sulfate, then it will displace copper and zinc sulfate is formed. Okay, so guys, This is also an example of displacement reaction because zinc comes above in the reactivity series. So that's why this is more reactive than copper and it will displace copper from its sulfate. I hope guys these points are clear to you. Now let's move ahead on the next slide and let's talk about the other important points. Okay students, so here we are. Now here we will talk about that how do metals and non-metals react. Although I had told this thing to you when I started this chapter or when we were discussing the properties of the metals and the non-metals. So guys, here we will see the same thing but this time a little bit deeper. So guys, we all know that metal lose electron and become positive ions. So they are called electropositive elements. We know this. So let's take an example. We all know that atomic number of sodium is 11. So if I write the configuration for it or if I write the electronic configuration for it, then I will say 2, 8 and 1. So this sodium wants to become stable. So to gain this stability, it will lose one electron and it will form sodium cation. This is basically the positive ion and it will lose this one electron. And this is the electronic configuration of sodium and this is atomic number of sodium. So I'm writing this here, atomic number. Now let's talk about magnesium. So magnesium comes after the sodium in the periodic table. So its atomic number is 12. If I write the electronic configuration, then the electronic configuration of magnesium is 2, 8 and 2. Okay. Now this magnesium also wants to be stable. So for becoming stable, it will again lose 2 electrons and it will form this Mg+2 ion where it has +2 charge and on the sodium there is +1 charge because sodium only donated 1 electron and magnesium donated 2 electrons. So that's why this will become +2. Now these two are cations. Okay, the positive charge are what? They are cations. Now after understanding this, let's move on to the next slide. And before going to the next slide, I want you to know that most of the metals, or you can say generally metals, let me write this point here, generally metals have 1, 2 and 3 electrons in their valence shell. Valence shell. Now guys, you might be asking that what is this valence shell? So this outermost shell is known as the valence shell and the electron in this outermost shell, or you can say in this valence shell, is known as the valence electron. valence electron. So sodium has one valence electron and magnesium has two valence electron. Okay. Now guys, let's move on to the next slide and let's talk about the other points. Okay. So this is non-metal. Now guys, non-metal gain electron and become negative ions. So that's why they are called electronegative elements. Let me highlight this. So these are electronegative elements. And the metals are electropositive elements. You can see because they are forming positive ions and they are taking electron, they are gaining electron and it is forming negative ions. That's why guys they are called electronegative elements. Okay, so I hope this point is clear to you. Now let's understand this with the help of a suitable example. So let's take chlorine for an example. So this chlorine comes, or you can say the atomic number of chlorine is 17. Okay, so if the atomic number is 17, then if I write the electronic configuration for this chlorine, then it will be 2, 8 and 7. Now guys, because the electronic configuration of chlorine is 2, 8 and 7, so it also wants to be stable. So for gaining the stability, what can it do? We all know that every element wants to complete its octet. So to complete the octet of this chlorine, it needs one electron. So if it takes one electron, then it will become stable. So you can see here it is taking one electron, it is gaining one electron and it is forming Cl minus ion. Okay, now its octet is complete, so it becomes stable. So this is the example of chlorine. The same way we can also see the example of another famous non-metal, and that is our oxygen. So if this oxygen, if I write down the atomic number of oxygen, then atomic number of oxygen is 8. It is what? It is 8. So what will be the electronic configuration? It is 2 and 6. So guys, this oxygen also wants to complete its octet. So what will it do? It will take 2 electrons because to complete its octet it needs 2 electrons. But in the case of chlorine, chlorine needed only 1 electron. But here oxygen needed 2 electrons to complete its octet. So if it gains 2 electrons, then it will become negative because plus, or you can say minus 2 negative charge will come on this oxygen. So you can see after gaining the electron, the electronic configuration of this oxygen is 2 and 8 and it has taken 2 electron. So that's why minus 2 charge will come on this oxygen. So guys, you can see that non-metals are forming negative ions, and because they are forming negative ions, so that's why they are known as electronegative elements. So I hope guys this point is clear to you. Now after understanding this, let's move on to the next slide and let's talk about the other important things. Okay students, so here we are. Now we will talk about how ionic compound is formed. How ionic compound is formed. So we are taking an example of NaCl. This is basically an ionic compound. So guys, we all know that to become stable, this sodium need to give it electron, or it needs to lose its electron, and to become stable this chlorine needs to gain one electron. So guys, what happens? This sodium will lose one electron, or you can say it will give its one electron to this chlorine. So by this way, what happens? This sodium element has given its electron, so it will become stable, because after giving the electron, the electronic configuration of this sodium will be 2 and 8. And after taking one electron, this chlorine also becomes stable, because in this case the electronic configuration will become 2, 8 and 8. So both the octets, or you can say octets of the both element is complete. So guys, this sodium is positive and this chlorine is negative. And we all know that if there is a positive charge and if there is a negative charge, so they will attract each other. They will attract each other. There is a force of attraction between these two charges. Okay, and this is what? This is electrostatic force. Electrostatic force. And guys, this force is very strong. Okay, so because of this force, this NaCl atom, or you can say this NaCl molecule is formed. And because this molecule is formed by a very strong force of, you can say, attraction or electrostatic force, so that's why this is very strong element, or this is very strong compound. So guys, that is the reason that ionic compounds has high melting point and high boiling point, because to break the bond between this is not very easier. Okay, so I hope guys this point is clear to you. Now after understanding this point, let's move on to the next slide. Okay students, so here we are. Here we will talk about the formation of magnesium chloride molecule. Okay, so basically this is also not different. This is same as we have seen the formation of sodium chloride molecule. So what is the atomic number of magnesium? The atomic number of magnesium is 12. So if I write the electronic configuration, then I will say 2, 8 and 2. So this magnesium element also wants to be stable. So to gain the stability, it will lose 2 electrons and it will complete its octet, and it will convert in Mg+2. And this is what? This is cation. This is Mg+2 ion. Now this chlorine again will gain 1 electron and it will become Cl minus because it wants to complete its octet, and after gaining 1 electron it will become 2, 8 and 8. This is basically its electronic configuration. Okay, now guys, this magnesium will give 1 electron to 1 chlorine atom because this magnesium has 2 electrons to lose. So 1 electron is given to 1 chlorine atom because chlorine only needs 1 electron. 1 chlorine atom only needs 1 electron. So that's why 1 electron of magnesium is given to chlorine, or you can say to this chlorine atom. But 1 electron is still left. So what will happen? This 1 electron will be given to this another Cl or chlorine atom. So thus Mg is forming bond with 2 chlorine atoms. Okay, so guys, you can see this is Mg+2 because it has loosened 2 electron, and Cl minus and Cl minus, there are 2 atoms of chlorine. Okay, so thus MgCl2 is formed where 1 Mg element or 1 Mg atom is forming bond with 2 chlorine atoms. So this is also an example of ionic compound. Okay, so I hope guys this point is clear to you. Now let's move on to the next slide. And guys, here on this slide we will talk about some of the properties of ionic compound. So guys, we all know that ionic compounds are also known as electrovalent compounds. As it is written here, these are also known as electrovalent compounds. Okay, so guys, these compounds are formed by the transfer of electrons. We all know it that in NaCl, what happens? This Na is given, or you can say it is giving its electron to Cl. So this compound is formed by the transfer of electrons. So that's why you can say that ionic compounds are the compounds which are formed by the transfer of electrons from a metal to non-metal. Okay, and this will always be happening that one atom is metal which gives electron, and the another atom which is taking the electron will be non-metal. Okay, so this bond, you can say this ionic compound formed by the transfer of electron from a metal to non-metal. Okay, now guys, the solution of the ionic compound will conduct electricity. Okay, because you might have known that electricity is conducted when there is free electron and when there is free ion. So guys, when this ionic compound is mixed with water, so you can say in the solution it will break into ions. This NaCl will break into Na plus and Cl minus. So because it has the presence of ions, so it will conduct electricity. So you can say in the molten state the ionic compound conduct electricity. So I hope guys this point is clear to you. Now let's move on to the next slide and let's see the properties of the ionic compound. So guys, they are formed by the transfer of electrons and are made up of ions. So this is the basic property which we have been seeing since a long time. So I hope this property is being by hearted by you. Now this is another property, that they are crystalline solid. Now what is crystalline solid? So I told you in the previous chapter that there are two types of solid, crystalline and amorphous. And what is the crystalline solid? Which has a definite, or you can say which has the proper arrangement of particles. Proper arrangement of particles. But here it does not have proper arrangement. Okay, so guys, the ionic compounds are crystalline solid. It means it has a definite or proper arrangement of the atoms. I hope guys this point is clear to you. Let's see this point, that they have high melting and boiling point, and you all know why this has high melting and boiling point, because they are formed by the strong force of attraction, because of the electrostatic force of attraction, and because electrostatic force is very strong force, so that's why these compounds have high melting and boiling point. Now guys, they are soluble in water but insoluble in organic solvent. As I told you that it will dissolve in water and it will split into ions, but they are insoluble in organic solvent. Now what are some examples of organic solvent? So petrol and kerosene, these are the examples of organic solvent. So they are insoluble in organic solvent. It means it does not dissolve in the solvents like petrol and kerosene. Now guys, the last point is they conduct electricity in molten state or in solution. So I told you that in molten state they are present in the form of ion, and to conduct electricity there are some conditions, that it should have free electrons or it should have free ions to conduct electricity. So because it has free ions, so it will conduct electricity in molten state. Okay students, so let's move on to the next slide and let's talk about some of the examples. So this is example number first, that why ionic compound have high melting and boiling point. So basically guys, as I told you on the previous slide, that ionic compound are formed by the very strong electrostatic force. So because this force is very high, that's why the melting point and boiling point of these ionic compound is very high. Okay, now let's talk about the second question. So this question says that write the electronic configuration of aluminum. So to write down the electronic configuration of aluminum, we need to know the atomic number of aluminum, and that is 13, because it comes after the magnesium. So now the electronic configuration will be 2, 8 and 3. And if you are asked what is the valence electron in aluminum, then you will say the valence electron in aluminum is 3. Now guys, let's talk about the last question, arrange the following metals in the order of their reactivity. Okay, so guys, we all know by the reactivity series, you can see here that this sodium comes on the top. So I will write this sodium here, and then you can see here after the sodium magnesium comes. Okay, so the reactivity of magnesium will less than sodium, and you can see after the magnesium the zinc or the metal zinc, and after the zinc this Fe will come. So we can also cross check this, that after the zinc ferrous or iron is coming. So that's why this is the order of reactivity. I hope guys this last point or this solution of the last question is also clear to you. So thank you so much guys. I'm ending this lecture here and we will meet in the upcoming lecture. Thank you so much.